Okay, so we're going to look at particle effects now. That's the main thing, but in the meantime we're kind of going to revisit blending and textures a little bit and using textures in different ways just to get to the point where we can start using these sprites in the particle effect. And let's just start here in our program and kind of see what it looks like at this point. Okay, so we have this model here when it's moving around. Maybe we can just keep that and try to draw the particle effect there instead. So in our code we have the game itself here, and somewhere inside the display function we should have this code here. So I have this model position, which is basically being affected by the Bezier curve that it's moving along. So let's just keep it there, except we're going to use this model position for something else now. So we're drawing this model. We're going to need to begin with in order to do a particle effect, because the particle effect is going to be built up of particles, and each particle, at least in this case, is going to be just a simple two-dimensional image projected into 3D. So we're going to make a class here, just put it here in graphics shapes and call it sprite. So new class, and call it sprite graphic to keep in the naming style with the rest. And well, we'll see whether this only holds the image and draws the image, or if this will actually hold the position itself as well. I imagine we'll just call sprite graphic here, basically steal the code here from box graphic, like so, and say this is going to be our sprite graphic. So what sprite graphic is going to do is we're simply going to create a vertex buffer that holds 4 vertices. So it's just a single side, single square side that we're going to draw. So this one is, I'm wondering if this should be in the X, Y, yeah, and Z is always fixed, so we'll just put Z to 0. 0.0. Like so, and what we're going to try to do is just get, okay, we'll use one normal, which, yeah, will be the first one, the one that just points along the negative z-axis, which means it points, no, along the positive z-axis, and imagine it points straight at us. This doesn't matter though in most cases in what we're going to use this for, because we're actually not going to light it necessarily. We're just gonna allow this to give the color of the sprite. It's going to be more of a light emitting particle effect that we're gonna use there. Okay, and then we have UV coordinates as well, and they again only need to be for them. So 8 in the UV coordinates, 12 here, 12, a lot of manual labor here. And then, yeah, we can draw this with an index array. 0, 1, 2, 0, 2, 3. Well, we might just do this as triangle 0, 1, 2. In which order are they? 2, 0, 2, 3. So that'll be triangle fan. Triangle fan. Just going to draw 4, and then we'll just do 0, 1, 2, 3. Okay, so we have some textures. Vertex buffer, normal buffer, UV buffer. Okay, this looks nice enough. Let's see if we have already in our assets folder here some texture that we can use. Text 01, yeah, fine, good enough. Okay, so let's go back into the game. Let's just make a new texture here and call it particle texture. And say particle texture with the text 01 PNG. So we should have our texture here. Yeah, okay, I made sprite graphic the same type of static class as box graphic. So we're gonna have to create that as well. While just getting into, okay, I'm just gonna see if this runs to begin with. Okay, fine. And I'm gonna see if I can go down to here again. Take model.draw out and say sprite graphic dot, well, this shouldn't be called draw solid cube. We're going to send in a shader. We're going to send in particle texture, and we'll just send in null here. So let's go in here and say rename this to draw sprite. No, oops. So let's see what happens here. Okay. Okay, this isn't easy to decipher. Okay, sprite graphic. Does anyone see anything wrong here? Yes, so this is too big, but I'm still just drawing 4. Let's see if this, okay. So now I'm drawing that, it's going away there, and it's just a flat image. And I don't know exactly how it's being lit. We go to this side, it's lit up. Do I have a light now? It's following me around, yeah, okay. So obviously the normal is pointing in that direction. Okay, so let's start by setting a few things here, like set material diffuse and specular, doesn't matter. Might as well just set that to 0, 0, 0 here. The diffuse for this, and emission we're going to set to 1, 1, 1. So now it should just be fully lit regardless of, whoa. Okay, yes, I got it. Do you know what happened here? Can you imagine?
The emission is just setting full white on each pixel.
Yeah, the emission, because I'm setting the emission after I set the texture. So I'm using this texture as diffuse. So I'm using this texture as diffuse, and then I'm adding the emission afterwards. So what I need to do in this case is to either say this is an emission texture and use it specifically like that, or I'm going to have to change my shader. And let's just do that. Well, let's look at the shader to make sure we do this right. So the fragment shader here is where we're using this. We're setting the texture as a diffuse texture, meaning that material diffuse equals what comes out of the texture. I think we should actually just we have here material emission, so let's just make a specific emission texture. And for anyone using a lot of values like this, there are two things to do this better optimized. One is actually checking if the emission is full, or if the diffuse is 0 or something like that, then don't do the calculations. If diffuse is entirely 0, you don't have to do the Lambert calculations. They're going to end up as 0 anyway. So that's one way to optimize. Another way to optimize is simply to make different shaders for different applications. So in order to do my particle effect, it would be sensible to just have an entirely different shader that only has emission, and I just set a color to white and a single texture, which is the emission texture. So it's not always the best idea to have a really complicated shader that does everything. But in this case, we're going to just keep adding to this one, so we don't have to spend time building the structure around switching between shaders. But it's as simple as shader.java, making a function on the shader, which is something like switch to this shader, where you simply call this GLUse program with the ID of this shader. So we can have several instances of the shader class, or even several shader classes with different types of elements that we're setting in each shader class. Each of them can be switched to, and we simply call GLUse program, and all the variables that we've set on each shader will basically still be set on that shader, because all the variables like the diffuse color and the model matrix and all of that stuff is set to a specific shader ID, so that'll stick with that program. So you can have different programs with different variables set, and then just switch between them as you draw different objects. So that's an idea for someone who wants to have a more complicated setup in their program, but doesn't want to have all the if statements and loops and stuff inside their shader. Instead, you can just do more simple shaders and draw each object with its own shader attached. Okay, so back to where we were here. So before, let's call this material emission. If it uses emission texture, material emission equals this, otherwise material emission equals material emission. This is pretty much correct, right? So now we have this variable material emission, which we want to use instead of the U material emission. So here we're using U material emission. Add this. This should be nice. So yeah, I'm working with alpha here. I'll just take that out and we'll put that back in later on. Because especially in this case, we might want the alpha to be taken from the emission rather than the diffuse. Okay, so then we're going to have to add uses emission texture. Okay, is there anything more you think I need to add here? Okay, so in the shader file, we're going to need to set this up as well and say I have the diffuse texture stuff, I have the alpha texture stuff, and I'm going to add the emissions texture stuff. Let me know as soon as I write something wrong here. Okay, then the same thing here. Okay, is this all you think? Then we have if uses textures, we'll add here the uses emission texture, set diffuse texture, this here thing, oh well, we can have that in there just as well. Okay, do we believe I've done everything right here? We'll go into sprite graphic and we'll say emission texture here. We might have both, but in this case we'll just say a sprite is not using diffuse. It'll be using alpha for transparency, but it's just using its own emission color. So we're going to set emission. Now I've done a lot of changes and not tested any of it, so we'll see if this runs. Okay, nice. What's going on there though? Seriously, what is going on here? What did I do to my shader?
And set the emission textures on.
Yes. So I guess I have to make sure then that in box graphic and in the other functions set emission texture to null. Okay. So we'll have to, yeah. Obviously, you'll probably want to just have a function on your shader that clears textures before anything else is set. So it wouldn't do this really, but have a, oh, let's do that later. For now, let's stick to this and see what happens here. Fine. Okay. So we have this emission texture, and we might as well go ahead in the sprite graphic and say it sets its diffuse texture to null then. Alright. This is good enough for now. So it's there, this sprite, it's moving around, and it's just a two-dimensional image. So let's make it a little bit more interesting. And let's start by just going into new GIMP here. Just new 256, 256. That's a nice even number. And it's nice to go here and use the gradient effect. You can set the shape of it from linear looks like this, to radial, and you can just find the exact center here, 127, 127. Oh well, this is good enough. Let's go right up to the side, so we have from white to black here. And let's just save this. Where do we want to put this? Stick it here and say gradient 1. No, sorry. Cancel. I'm going to export it. Export it as a PNG. Export. Here. Okay. Where am I again? Here. Here. Let's take that, put it into our textures folder here. All right. And just see if that image is now here. Okay, so now we have this little kind of energy ball, and it actually almost fakes itself as, while we have the black background on it, just almost looks like it could be a three-dimensional object or some kind of energy or some kind of source. As soon as we go around here though, obviously we see its edges. We see that it's just a two-dimensional image stuck there. So what we're going to need now is some way to blend this into the background. So we can go into our game class here, and where was I? Enabling, create here. Am I enabling blending here, or are we doing it here? Or maybe just in the display function here. Okay, so let's try to enable blending. So as soon as I enable blending, what I'm doing is I'm telling OpenGL to basically mix whatever pixel I'm putting in now. The color I get out of the fragment shader, instead of that just overriding the frame buffer, it will take the color that's already there and it'll mix that in some way with the color I have and then stick that in there. And these blend functions are basically telling OpenGL what should I multiply the source with, which is what I'm putting in, and what should I multiply the destination with. So right now I'm using source alpha and 1 minus source alpha, meaning it's some kind of transparency based on alpha. But I'm going to try something else, and I'm going to say I'm going to use source. Well, no, I'm simply going to say GL1 here. That would mean it takes this entire color, and GL1 here as well. So it simply adds the colors up. So we'll take whatever we're putting in there, multiply it with 1, meaning we have the full thing, take the other one and multiply it with 1 as well. So we just add the color that's there with the color we're putting in. And the reason this can work, well, it can't, but it makes a pretty cool effect on the... Okay, the reason it's not working is the order in which we're doing this. So I'm going to go into the game class here, and I'm going to say I'm drawing pyramids here. I'm going to draw those first before I draw all the other stuff. Wonder how soon I can do that. See if we can just draw them here. Okay. So now only the color is being added here. But this happens because the surrounding is black. Because it's fading to black, then we can use this and allow it to fade in. So if we want our image to be any other color than black, or we don't want to use black as actually part of our particle, we're basically losing the ability to use the color black here, because we're just saying this is just fading based on color. And what we should actually do as well is we should take the blending here and enable it here, but disable it before. So, and again, you can add stuff like disable and enable blend into the functions that draw the things themselves. We can enable blend inside the sprite draw function and disable blend inside the box draw function, or any way you want. Right now I'm just doing this all in the single function. So now this is solid, but this is being blended onto. Obviously we get that cut there because it's two-dimensional, but this can kind of be viewed from any side. If there's black behind, we just see the image like it is. Otherwise we're blending it onto the rest. So this is pretty much trusting that we have a sprite that has a black background. So what I'd like to do instead is to say I want to use the alpha now. So I am going to go into where I call the sprite here, and I'm going to say I'm going to use particle texture here as, let's see, okay, so I'm going to take some other texture here and say, okay, texture will simply be our nice little text 01 here. Then I'm going to stick, let's see what this looks like. So now I have this image. So okay, let's look at what's happening. This clean cut here is actually happening inside my shader. Somewhere in here I'm saying if material diffuse.a, which is the fourth coordinate, so any vec4 we can access it either by using x, y, z, and w, or RGBA. The shader doesn't know what we're using as color and what we're not, so it just has these two ways of accessing. So to access the second coordinate, you can use .y or you can use .g. So .a means the fourth coordinate here. If it's less than 0.0, I simply discard this. So I'm gonna take this part out of the shader, so we fade all the way out. Right? Is it blending? Yes, it's blending. But it's not blending against the background, and it's not blending based on. So what is the alpha now? I kind of want to set the frag color alpha to, let's say material diffuse alpha should be 1. So then, oops, sorry. This should be, where was it going to run? This should now just be completely solid. Of course. Anyone guess what I'm forgetting here? I'm still using this blend function. Let's look at more types of blend functions here. Let's take this, just comment this out since we're doing this in these places here. Okay, so we have more possibilities here, like this one, which uses the alpha. Alright, so now we're getting the alpha from the texture, both the emission texture and the, well, probably not from the alpha texture. Am I using that? Yes, I'm using the alpha texture, of course. So let's see what's happening here. So we're taking the alpha texture, which is set there, and I'm setting this to material diffuse.a. So that's fine. We're still using the material diffuse even if we're setting it to 0 in this case, so we end up using the alpha value of that, and that's just fine since we're using that in our final calculation here. And I'm setting it here. I think actually it should work without setting it specifically now that we're setting it now. Okay, we need to do that in our shader. So here I'm setting the alpha value of the frag color out. I set the frag color to this, and I set the frag color alpha to the material diffuse alpha. And I'm using that for my alpha texture anyway. So we can see the difference. Here we're using this alpha. You can see if you look at the center, it's kind of not very see-through right at the center, but it fades out. If I skip this line, then the color is the same. So this is the color sprite. It should be absolutely solid now. Yes. And so we have a sprite here. Okay, so add this. So we have two textures now. We have the emission texture giving us the image, and let's set some more interesting image here as well. So let's go ahead and open GIMP again. Let's just set a new gradient here. Can't I like just set the gradient myself? Here we have transparency gradients. Can I change the colors just here? Let's do something like this. And the second color, something like this. Go to 128. Good enough. I'm going to do it the other way around though. Something like this. file, export as, fire gradient, export like so, like that, stick it into here, game class, and say our regular texture is going to be fire gradient. I don't know if it was a capital letter or not. Okay, so now we have that. It's also being mixed, the rest of this. Alright, so we have ways of kind of manipulating what we're drawing here. We're still drawing this effect as a single image. But still, using this in distance can actually be a pretty nice effect. The problem here, and we'll wait a little bit with addressing that, but I'll kind of talk about how we can do that. The problem is obviously when I go around this becomes entirely flat. But we would like for this to always be turned towards the camera. And a nice way to do that is you can look at the camera class itself, how we're set using the look at function, where we have the point I and the point that the eye looks at, and we set up basically a coordinate frame that is directed exactly in the direction that the camera is looking. You can use those same calculations as we do in the look function in the camera class, except you can take the point where the sprite is as the eye point, and you can take the point where the camera is, which is where the sprite should be facing all the time at the camera, as the look point, and you can do those same calculations and you'll end up with a rotation matrix. You can just then take away the position part of that, because that doesn't really matter. But if you have the position part there, just make sure that you're not, when you're drawing the particle, that you're not translating or anything first. And then you can just use that as your transformation matrix, as your model matrix. So you can just put that calculation into the model matrix, and say by using these calculations I can build a model matrix of the sprite so that it's always turned towards me. The size of it will be the same, but this will include the position and the orientation of the sprite so that it's always turned towards the camera. I'll see if we have time later to implement this. But for now, we have this sprite, we can move it around, and it's always see-through in this way. The problem now is, since we're using depth testing and putting something in the depth buffer here, if we draw this before we draw the pyramid, even though we have this nice blending, it won't have anything to blend with. It'll simply blend with a black background, and then we draw the pyramids. So we can, for instance, say before we draw this effect here, we can here disable blend and enable GL depth test, and at the same time, when we draw the pyramids, afterwards we'll say we're going to disable GL depth test and enable this. So if we take the pyramids again and draw them afterwards, okay, now they're simply being drawn over this because we're not using depth testing. So yeah, it's sort of there. Yeah, so we can feel where it is, but as soon as pyramids, it seems like it goes behind it. So it's a pretty weird position effect, because it really looks like it's closer to us than the edge and goes behind. Because we're not using depth testing when we draw it, then we draw the pyramids afterwards, so they have no depth data to cut at. So they simply override this. However, if we draw the pyramids before, which would be here, and don't disable the depth test, just have depth test enabled throughout. What happens instead is that this is correct. Depth test, pyramids. If we draw them afterwards, we'll have the depth test enabled the entire time. Yeah, okay. So if we draw the blended object before we draw the pyramid, either we have depth test and this happens, or we disable depth test and it just goes behind. So we have to make sure that anything we're going to blend, we have to draw after the solid objects. And if we want to blend an object onto another blended object, we have to make sure that we draw the one that's closest to us last. So we kind of have to order a little bit in which order we draw things. So this works regardless of whether we're using the depth test or not. But we'll see later on when we start doing the particles, if we have them in random locations, that the depth test can be problematic as well, kind of blending the particles together. Okay, so enough with this for now. So now we kind of want to build some kind of particle effect on top of this. So that would, I guess, go in graphic shapes. Just add a new package here. Okay. New class. We have the class sprite. Let's add the class particle. The class particle should have a texture. Let's say it has an alpha texture. Alpha texture. And yes, this texture. And finally a point position. What we're going to do here for the particle is we're simply going to say we're going to have a public draw function that calls matrix dot main dot add translation to position X. Nope, the other way. Is this okay? 3. So why does it like draw function? Yeah, okay. And then we simply call sprite graphic dot draw sprite. We need the shader here. Shader. Need to send that in here then. This one. Texture. Or we can just call this emission texture actually. And we need a public particle that takes a point 3D position, texture, emission texture, and the texture alpha texture. this dot position equals texture. Okay, so this would be good enough for a particle. You just need to set each particle with a position, with a texture, and then it'll draw itself. And we should be able to just load this texture once and then give all of the... Actually, in that case, we might actually want to... Well, let's look at that later on. Maybe the particle effect should just set the texture so we don't have to set that over and over again. Just to make it a little bit more optimized. But now we're going to need a new class, which we'll just call particle effect. Okay. So now we need to kind of start thinking about what a particle effect does and what it entails. So let's imagine that this will be, we'll make a new instance of this class for each particle effect, so it won't be like a static class. And this class needs to keep track of all the particles that it's drawing. It needs a way of making new particles and making particles disappear. It needs a way for us to say how fast these particles are generated, in which directions they go, and keep track of all that. So what data would this particle effect need? So now we're finished with all the setup and kind of gotten into the interesting stuff. So the particle effect itself probably needs a position, 0.3D position. And then we can kind of decide, let's go into the particle and do one more thing here. We might want to decide then matrix dot main dot push matrix. You might want to decide whether the particle's positions are relative to the particle effect's position or if they're absolute. But we'll just see in a while, I guess, which one will work better for our implementation. So it has a position itself, and this position will at least be used for it to generate new particles and give them positions, or it'll be used for a translation in the draw function, and then the particles will simply have relative positions to that. Okay, what more does it need? Let's just make a really simple particle effect to begin with. So it has its position. We're going to need a function, public void update, which takes in float delta time. In this case, it's just going to be incremental time here. And even if you're doing an animation where things are using the absolute time since the beginning of the program, it's okay to use delta time as the incremental time into the particle generating part itself. But you might want to update the position of the particle effect using the entire time, the elapsed time since the beginning of the program. We'll just see how this works later on. So, what will the update function do? So we probably need something more here. Let's start doing the update function and add things as we need them. So we don't have any speed for this, we just have a position. We're going to imagine that this is just a stationary effect to begin with. Is there anything that we can... Well, what's the update function going to do? What happens every frame in a particle effect? Let's imagine we're going to make something like a fire. It's a continuous fire, a continuous energy effect. And it's just kind of a nice effect that moves around and kind of seems like it's moving always in the same direction. Like fire is always moving up. It's being generated by the candle or in the fireplace, and then it's just moving up. So what does this update function need to do? Add particles, okay. So add particles to what? Yeah. What type of list would be nice for this particle effect? We need something that we can kind of add to and take the the oldest things off of?
Q.
Q, I guess. Isn't there a nice Q, or is it called DQ? No. Is there a nice Q in Java? Q particles. Java util Q. I wonder if you can actually. Let's start with this. So public particle effect. Should probably send the position in here. Okay, so let's see if we can instantiate this Q. Particles equals new. Okay, this has to be a Q of particle, right? Equals new Q. I wonder if it allows this. Can you instantiate this? What nice implementations. Java Q implementation. Okay, linked list. Oh, fair enough. If this works. Yeah, okay. Okay, so, all right, how are we gonna add particles? When are we gonna add particles? How often? How many particles are we gonna add? How can we make these decisions? Do we need to add more here? We have a position, we have particles. Like, do we need some kind of rate? Let's add that at least as a variable, so we can change that. We can hard code some things and then add them as variables later, but I think float, I don't know, generation interval or something like that, rate. Let's use rate, and imagine it's how many per second we want to build here. Rate. Okay, so how do we set this up? We get delta time in. How do we set up how many particles we should make? And where they should go? Is there a nice way to do this? We're probably going to need some kind of.
You need to count delta time, huh?
Yeah, we're kind of gonna need to count delta time and say, okay, we probably have some leftover time since the last frame. We'll add that to the delta time, see how many we can generate this frame, and then basically add the leftover time again. Okay, so let's add a private float leftover time here. And just start with leftover time equals 0. So let's start with, okay, we get delta time in there, and delta time is a float, so that's just passed by value, so we can just say delta time, not ruining anything by saying delta time add leftover time. Then we can say for we don't really need anything in the first one, right? We just need to say, or it's more like a while loop. While delta time. Okay, so rate tells us how many per second. So we kind of need another number for this, right? We'd probably add a private floating point here. That's called particle interval. Let's just say that. yeah, particle interval, and then we can say when we add the rate, instead we say this dot particle interval equals what? If rate is 1,000, then the particle interval is 1 divided by rate. Okay, so then we don't have to calculate that again. While delta time is bigger than or equal to particle interval, do stuff and end by saying delta time minus equals. Would this make sense? Would we go through this for loop the correct amount of times? Okay, so then we'll say here particle. Okay, so I may have failed a little bit here. Okay, so particle equals new particle. Okay, so we're doing this position equals position, but we're not doing a copy constructor here, so we can't really throw position in here. New 0.3d, sorry. D position dot x dot y position dot z. So, and we add, okay, so the particle effect should really hold on to the texture, right? So it generates each one with the texture. So let's add that here as well. This should all be private. Okay, so texture, emission texture, and alpha texture. Yes. Wait. Yes, this type of texture. Okay. So then this would have to, let's go into particle and just steal that. It's here, rate, emission texture, particle texture. These two lines here as well. Okay. Does this make sense? So okay, we're adding a new particle and it gets this position, and at some rate we add a particle on top, gets this position, it gets these textures. Okay, let's, just so we can test everything that we do. Display, this will need a shader. And this should say for particle in particles. We can do this with list, right? We say particle dot draw with the shader, and this Viad is not a return value. Okay, so this works. So should we have some kind of lifetime of the particles, or should we just test this now and see them just get constantly added up? Let's get a test on this, just see that things are working that we've already put in there.
Would we see it, because you're always generating it at the same place, would we see something happen now?
Let's see. Yes, I am always generating it at the same place. I realized that. I was just going to see what happened. There is blending going on though. So let's see what happens.
Yeah, sure.
So they'll be added. So let's see. Okay, texture. So we need something here. Particle effect here. Just make sure that everything that we're doing here. Okay, particle effect equals new particle effect. Okay, it gets some position here. Okay, let's just take this point since it's the start point of the Bezier motion anyway. Rate, let's say not too many per second, 3 per second. Okay, and we'll say text here as the emission texture and alpha text as the alpha texture. Let's go down to where we draw. So here we're drawing, just calling sprite graphic. So instead we're going to say particle effect dot, oh, we don't have a draw function.
You're on the class.
Oh yeah, I'm on the class, that's true. Particle effect dot, did I call it display? Oh, let's change that just to be consistent here. Particle effect, refactor, rename, draw. Let's save everything. Let's just see what happens now. Okay, nothing's happening. We're giving them its position here. When we draw the particle effect, it should draw all the particles. Huh, okay, I can see what we're doing wrong. What am I not doing here? I'm not calling update. Yes, there's another thing too. So I'm not calling update in the game class. Let's call update. Let's start with that. So in our update function, we have delta time here. What are we doing here at the bottom? Yeah, motion, get current position. And let's call particle effect dot update. Will this work now? What am I not doing? Yeah, we're not keeping the leftover time, but that shouldn't matter. Okay, yes, true, I forgot that. So once this is done, we should say left over time equals delta time, since we've been taking off with delta time the whole time. There's one really important thing, meaning that this will do nothing. This for loop will have no, yeah. So particle up equals this, and so we say, what was it called? Particles dot add particle. I guess we could just as well just stick this entire thing into here. I don't know, it would be optimized in the compiler anyway. Oh. So okay, so we're actually adding that to the queue now. Let's see if something happens. Huh. I'm using a different, wait a minute, is it being, yeah, I'm just using that too. It added one, oh yeah, okay. So let's use the correct textures, I guess. Particle, no, in the game where I made them, I used alpha text here. I should have been using particle text. Okay, I'm using very badly descriptive names here. Do we see them add up though? No, because they're using this type. Okay, let's look at the blending a bit now. So this is kind of alpha blending. So it's just being blended with the alpha into the background. So it's using its own alpha value. Let's look at where we're setting this. And I think we should actually say that this stuff here is here, let's just put it, let's say our particle effect is the only thing that's using blending now. So let's let it kind of control the blending itself. So the particle effect here will enable blending, draw its particles, and then disable blending. That way we can set this as variables as well and say different particle effects have different types of blending. This one is using source alpha and 1 minus source alpha, meaning it's just taking a weighted average based on the alpha value of what it's putting in there. So I would like to instead say either GL source alpha and then GL destination alpha, which means I'm using the alpha value of what's underneath. That way, however, when I blend again and again and again, each thing that is blended on top of will always, its alpha value will be used again and again. So if it has an alpha value of 0.3, once I blend something else on top of it, it will go down to 0.09, right? And then if I blend something else on top of it, it will be 0.027 and so on and so forth. So a nicer way would be, say, source alpha here and GL1 here. So we only light it up, but we don't light it up fully. We light it up based on its alpha value. So let's see how this looks. They're still not being added on top, but you can see it's very different here when it's added on top of the blue layers. So we're only ever seeing the one. I'm using depth test. This was supposed to be disabled. They're put on the same place every time, so they simply cut away. Only the first one gets to the depth test. There. Okay, so they're constantly adding new and new ones. Interestingly enough, there was obviously, okay, there's a tiny little bit of blue, I guess, in that gradient, since some of it's going to white now. And if we wait long enough, since there's a tiny little bit of blue in it, I guess in the end the whole thing will just go entirely white. So this is not quite what we're looking for, but we can see that our particles are being added up constantly. Alright, so what next? What do we want to do now? We have the particles, we have some kind of blending on them. They're just kind of being added. Okay, let's give them a direction. So a particle itself will now need some kind of update function, and it'll need a direction. So vector 3D, let's just call it speed. Alright, now let's add an update function here. Void update delta time. So we'll say position dot add vector dot scale vector 3D dot. Don't I have any scale function here? Add let's see if I have a scale function on speed dot. Okay, I have scale here, but we don't want to use that because we don't want to actually change the. So let's just go into scale, add a new function here and say public static void scale vector 3D v dot. Okay, return new vector 3D v dot x times s y dot v dot y, I guess just times, so v dot z times s obviously. Okay, so now we have this function. In the particle, let's add here vector3d dot scale, speed, and delta time. Okay, so now we're adding some speed, and let's say we need the speed as well here. So vector 3d speed here. Okay, what is wrong here? Like so. Particle effect now complains because we're not sending any speed in here. So I'm going to have to go down here and say this is also going to add a new vector 3D. Well, where do we want them to go? Let's just start with 0, 1, 0. Just to have something here. Like so, and inside update we also need to do this. Or actually, now there's a question. All the particles that will be added in the same frame will now have the same position. Don't we kind of need to update them based on how far they've already gone? Does that make sense? Or we can just back them up. Since the leftover time is higher as we...
You just update them with the value, whatever value of delta time is
left
when they're created.
Yeah, but we're taking off of delta time when they're created, so the first one created should actually go further. So if we update them with delta time...
The highest value first.
Yeah, the first one has the highest value left of delta time, and it's lower and lower. Yeah, so we should then, okay, so let's say this does update on delta time, except we should do this before. We should say this is what we do to the particles that are already there. Then we say delta time plus equals leftover time, and then for each of these particles, so then we need to change this again and say particle equals this, okay, and then we add the particle, but we also have to say particle dot update delta time, yeah, because why did that happen? Alright, so particle dot update delta time, for the first one will actually have delta time plus the leftover time, so that should actually have been created a little bit before this frame. It just didn't have enough, so it should be gone a little bit further. Okay, I think this should work. Feel confident about this? So they're all updated with delta time. Delta time is always getting smaller, so the last one is just updated with a tiny little bit to get them to where they should be in this frame. So they have this speed, we update them here, and we finally add the leftover time here. Okay, so we're updating the particles based on some speed, and we need to set the speed. Yeah, we're just setting that to a fixed amount. Let's see what happens now. Ooh, I have no idea. Okay, they're not moving. Yes. If we go to particle, we have update position add. We translate to the position. Any good ideas here? The particles are being updated. Wait a minute. Why are they moving? Yeah, okay, we're adding that translation in the beginning. We really shouldn't be doing that. That should be part of the particle effect here. Say we're going to add a translation to its own position. Actually, no, we're giving the particles its position. So the particles have absolute positions, meaning that in the game we shouldn't really be doing this extra translation here. Let's just skip that for a while. Set model matrix. Okay, someone probably said that earlier, but we forgot then. You need to actually do that as well. You need to set the model matrix. So we were just fixing them to positions here. So the particles themselves should add their translation and actually put that into the model matrix. Let's see how this works now. Okay. So we have particles, they're being generated, and then they just go right up into the air. Alright, so something's happening here. Okay, let's add something like create them with a higher rate. That would be cool. A rate of what, 30 per second? Okay, so that's something. That's a bit too saturated though, right? So we'd like to take that a bit down. So what I want to do is kind of add a little bit to the alpha value that we're using here. So I want to say, let's go into our shader and fix that a little bit. Right now I'm just saying I'm going to use the material diffuse.alpha, and the material diffuse.alpha I get from here. If it uses an alpha texture, I put this in here. What I kind of want to add to that is to say material diffuse.a. Let's multiply that with material emission .a. So we can actually, if it uses an alpha texture, it does this. Otherwise, the material diffuse will have an alpha value anyway if we set that in the shader. And I'm going to add the emission alpha value to that as well. I'm going to see how this works. Well, actually, either that, or we can just either this, or we can instead say we're going to use the. So let's go into the particle effect here. The particle itself. Okay, let's just say, before we draw all these particles, we can go ahead and say shader dot set diffuse, set material diffuse to 0, 0, 0, and then we'll use the alpha value here. Let's say 0.3. Alright?
Are you recording?
Yes. 0.3. Okay. For setting the material diffuse, let's go into the shader again and make sure if we're using the alpha texture, we want to add this, but let's say that the alpha value itself will actually be an effect of it as well, a part of it as well. So we're not just adding, we're just not just setting it, we're multiplying it together, meaning that we're taking the alpha value that we set for the diffuse and we're using that as our main alpha value, and then we add the alpha texture as a layer on top of that. And again, like you see, we can do this several different ways. So let's see. Okay, it's still very, very saturated. So let's see if this actually has an effect now. Setting this to 0.03. Yes, it is affecting it. Okay. So this is still a ridiculous particle effect. But we can control its main alpha here, but we also have the alpha value fading it to the side so that it's not too sharp a cutoff on the circle. So now what do we want to do? Let's make this a little bit brighter. 0.1. Okay. So what do we now want to add to our particle effect? So we have the rate at which they're generated. We want to have something like a lifetime so that they're popped off. So if we go up here, let's say we have the particle interval, private float particle lifetime. So we have rate, we have float particle lifetime. So we can go here and say this dot particle lifetime equals. So how can we keep track of this? So now we have some particle lifetime. Let's imagine every particle lives for 3 seconds. How can we keep track of this in the update function? Should we put a lifetime already lived on the particles and kind of poll that? Or can we actually, with this queue structure, just say we know we're generating them at an even rate? Can we also just throw them out at an even rate? But at some point we need to keep track of some lifetime, right? How could we do this? Can we do this just while we're putting stuff in? Or do we need something like private float, just lifetime? And say in the beginning we set lifetime to 0, so this is how long we've lived. So we don't want to start throwing them out until we've reached at least particle lifetime. So we can now say, okay, let's just go down here after we've added and say if particle lifetime is greater than particle lifetime, what do we want to do here? I guess we always want to say lifetime plus equals, we can't really say, well, particle interval. We want to do that every frame. But if lifetime has surpassed particle lifetime, we could actually just, there's another thing we could do. We could use particle interval and the particle lifetime to find some kind of just maximum particle count and use that as instead. Would that be a better idea? So basically calculate how many particles we can have. So if we have a particle rate of 30 per second and we have a lifetime of 3, we can simply multiply those together and say that means our Q should never be bigger than 60. So we can just ask the Q, if you're bigger than 60, throw one out. Would that be a better way to do this? Okay, so then we don't need the lifetime. We don't need the lifetime itself, but instead we're going to have a private, should we have a floating point value to have it very exact, or should we just put it at an integer and say it's not that exact a science?
The size you were comparing will always be an integer.
The size will be an integer, but the rate at which this will, I don't know. Yeah, well, let's keep it at an integer. So private integer max particle count. So that's what we're going to keep track of. So we don't even need particle lifetime though, do we? We need to get that. We get particle lifetime, but what we're going to do is we're going to say this dot max particle count equals particle lifetime times rate, and integer of that, or we can round that up or round, you know, whatever. We're just rounding down now, so it's not going to be that exact. So that's going to be our max particle count. So then we should just be able to say, we add a bunch of particles, and we can just probably go in here and say, it doesn't matter if we do this each loop, this is all happening inside one frame, so we can just as well go out and say, for int particle count equals particles dot size. Okay. Particle count is bigger than max particle count. Why is this not happy? No, never mind. Particle count minus. This makes sense.
The update is the particles or something.
Yeah, then in here we should be able to say particles dot, is there a remove function? Yeah. Okay, so this should give us an error here, and we're going to say the rate is 30. The max particle life, let's just put it at 2 seconds. Okay, so now it's being fixed there. But obviously it's not a very interesting effect since they all go the same direction. So now it just looks like, well, it's a nice lightsaber though. Okay, we need more speed here and not particles. Let's say 3. And then we have the effect of turning on a lightsaber. Oh yeah, then we need a shorter. Okay. I had more speed, which means we need to go ahead in the game as well and say we need a higher rate, but also a shorter lifetime. So then we'll get the same length, the same effect, except it'll be faster. You can play around with those things. Okay, so we have a few minutes left here. So now I can do something really interesting. Let's say the lifetime is a little bit longer. Lifetime of 3 seconds for now. Not so high a rate. And let's go back into the particle effect. Okay, now we need to do something with his speed here. And again, you can see already now how many things you would need to set in order for this to be absolutely generic, because we need kind of the average speed of a particle when it's generated. We also need kind of a direction vector sort of, or direction, general direction and a direction angle, like how much all over the place can it go. But I'm going to make a vector 3D speed here, particle speed, equals new vector 3D. And the question is, how do we want this to look now? If we want this to be some sort of kind of flame. So I'm going to add to this particle effect a private random here. Equals new random. Okay, so what we want to do here. So particle speed, now it's going just straight up. We like kind of some kind of interval. Can't we do rand dot next float? No, I can't do that with a bound. So next float will be between 0 and 1. If we do that on x, how can we kind of stick that to a specific direction that we're thinking about? So y, well, we can start with this just to see something happen. And then say we're going to put particle speed in here instead of this vector.
Just fix the y so they are.
Okay, now we've already got something a little bit more interesting. So, okay, this is going obviously in this XYZ all positive direction. So we want this to be more up. So let's set this now to, okay,
Fixed y.
yeah, we can actually set y to a fixed value. So we can say y, well, maybe not fixed value, but next float, let's say plus 0.5. So it'll be somewhere from 0.5 to 1.5. 0.5f. Okay. Let's take x, which is now from 0 to 1, and say we want that to be minus 0.5, so it goes from minus half to plus half. And we'll do the same with z. Let's see how, no wait, z, yeah, z. Okay, so now it's going generally, okay, it doesn't look like flame, it looks like smoke, which is still lit up like flame. Okay, again, this problem. We can see that they're going in the right directions, but they're not really facing towards us. So we're going to need some way of fixing that. I guess we don't have time for that now. I'll add something to it. So we have this. What could we add to make this more interesting? Obviously, one cool thing for any particle effect to add is more particles. So let's make it 130 here, the rate. All of the things the same. Okay, that's a bit much, but you know. Okay, so we've made more particles. One thing we can do then is to say, this should maybe be a variable now. This variable here. Okay. So how's that looking now? Probably if we had a little bit more white in the center of the image itself, we'd get a more interesting effect here. A little bit more blue in it. It's so much just yellow and red, but that's something that you can play around with. Again, the problem of them facing. One thing we could do like a Y rotation and have that randomized as well. So one way of fixing this, rather than actually having every single particle face the camera, is to say particle model matrix main dot add rotation y. And let's just say a rotation angle or something like that. Say we're going to add this to this here. We have speed, we have float rotation angle. Go ahead and say this dot rotation angle equals rotation angle. Adding float rotation angle to here, giving us an error here where we're making them. So we have particle speed, we need to add something, so random, not random dot next float times 360. No, do we need that? No, we kind of only need 180 degrees. But do we need 180 Yeah, we need that. We need a full 180 to get all possible. Okay, this should not be a semicolon. So let's see if this is working. Okay, so now the effect is a little bit weirder because we see at the side of some of them, but that means that we can now go around it and it looks equally weird from all sides, not more weird from one side than another.
Would it look weird if we would have, for each particle, we would have two planes that would go?
No, that's absolutely another possibility. So let's try that. We can still be adding this. Let's just go into the particle and say we're not going to add this rotation. Instead, we're going to add a Y rotation of 90 degrees, right? Add a Y rotation of 90 degrees. And we're going to set the matrix and we're going to draw it. And we're basically going to push the matrix here. Y. It's me accidentally hitting the mouse pad on the laptop, sorry. Okay, so push matrix. I'm going to push the matrix here, do all this. I'm going to pop it and then I'm going to draw it again. Or actually, no, I don't need to do this. I can draw it once. Okay, translate. I draw it. I rotate. I draw it again. And then I pop. Okay, so I don't need to do the extra push. Okay, so this should make every one of them. Am I still adding the other rotation? So I'm not adding the rotation angle rotation. Did it look weird? It still seemed like...
We need to maybe lower the alpha value because we are not drawing the double the amount.
Yeah, what's happening above here? Yeah, we're now drawing double the amount of, yeah, that's true. So we can either lower the alpha or we can lower the emission. So the particle effect, let's lower the alpha even more, 0.02. Well, we can still see that some of them are being displayed. I don't know. This is just something you should... So from some angles, you can kind of see that happening. Another thing that makes this not look very much like a flame. Why is this from some... Yeah, okay, it's most, when you're looking at it diagonally, it's the most kind of powerful, the effect, because then we're seeing through both of them. Whereas when we're seeing directly on, it's a little bit less impressive because one of them is being seen right from the side. I don't know. This is one way. The best way would be to actually just make sure that they're always rotated towards the camera. You can do that in many ways. You can go into the shader and just kind of draw particles in a different shader where they're kind of set up in the I-coordinates. You can also use just the I-coordinates in that you can take the model matrix and the view matrix and multiply them together and multiply that with the particle before you send it into the shader, and then have a specific shader that only draws it from there on, and then you can rotate it in that space. It's, you know, so rather than drawing it in the kind of absolute space, you draw it, at least the rotation of it relative to the camera. There's a lot of different ways to address this, but one of them is simply to set up a model matrix that does the same calculations as the look function. and then sets that coordinate frame up as a model matrix. You have to make sure that you don't then use the inverted model matrix that we use to set up the camera view matrix, but a regular model matrix. Alright. I don't know. We have particles here. It would be nice to have some kind of, I don't know, gravity towards the center, taking their speed and kind of gravitating it towards the center a little bit. I don't know how we could do that without making the particles very kind of particular for this effect only. We can always say speed dot x equals speed dot, or multiply that with something like 0.9 times delta time. So that would be 0.9 per second. No, that wouldn't be very big of an effect. Let's try something smaller, see how this happens. And do the same for z. Speed.z. I don't know, this might do something. Okay, that's a little bit too much. So it's somewhat gravitating towards the center. Again, it's too much. 0.9 was even. Okay.
So let's get it divided by delta time rather than one.
No, I think this is the effect that we're looking for. It's just, it's happening pretty fast.
Yeah.
Delta time is close to 0.
Very quickly.
Oh yeah. I understand what you're saying. So it should be kind of what, divided by something very close to 1 times delta time. So we could say like this. Let's say no, then it'd be get huge. I'm working the delta time in wrong here, aren't I? So I want to multiply this with 0.95. How will we do this?
Need the ratio of.
How can I use the delta time here? Do I divide by delta time? No, that would make it huge.
You need to subtract from x something multiplied
Yeah.
by delta time.
Yes. Exactly. So maybe if we say per second I want x to be, but then it'll just end up in the other direction. I can't just subtract from it. I want to kind of subtract from part of itself. So I want it to go closer to 0 each frame. Well, let's see if we just do it like this, 0.9, and not use delta time, just to see if the effect works. We can actually use a bigger number here. Now it's happening per frame, so we're going to have to use a pretty number pretty close to 1, I guess. I don't know. These are just ideas that you can do with your. It starts distributed. That's not enough. 9. The idea, at least, is to kind of have it gravitate towards its center again. Now it starts basically going a little bit outwards, but ends up going straight up. Yeah, of course, they will do that. They'll just end up going straight up. They won't end up going like back together. I don't know. This is more complex than I was thinking of. We could figure this out though, yeah. basically subtract to it the difference between it and 1 or something like that.
In the last time
So I can take speed x, so I subtract speed x multiplied by 0.9 and delta time, and subtract that from it. Does that make sense? So I take the difference. So if speed x is negative, I'm taking it towards 0. But I actually want to subtract kind of from the original speed x. So maybe I'd want to say I'm going to have a variable here called original speed. Speed equals speed, original speed equals. But then again, obviously I'm making this specific for this particle effect. I'm just doing it in x and y and x and z equals new vector 3D speed dot x, speed dot y, speed dot z. Like so. And then say I'm going to use original speed in here. I have no idea at this point. Okay, now it kind of goes outwards first, and then inwards. Let's make it a little bit less. See if it can go outwards a little bit and then start coming back in. Okay, so something like this. But obviously this would have to be some kind of variable that we set. Okay, let's not make them live so long, and let's make them go a little bit faster as well. So if we go in here and say, what was this? The rate. It's nice to have that long. Let's have this less. And I don't know if we want the speed less or what. Like so, and then we can make this effect here a little bit more again. Or is it less now? Yeah, we can actually make this higher anyway. It's not a percentage anymore. I don't know. It's got something. Does it make sense? Not really. But it's not too far from looking almost like a flame type object. Then all we need to do is to change the colors of this to blue, and we have a nice energy effect coming from the back of a space shuttle or something like that, or a spaceship, so on and so forth. Are there any questions or anything you want to do with this more, since we've gone through making this particle effect now? Now we're at the point where we can play around with it and try new things. If you want to make smoke, you could just change the type of blending that you're using and say, actually, I'm going to look a little bit at my particle effect here and see what happens if we enable depth test again. Now that we have it randomized like this. Nothing. That's not at all what I expected. We're enabling blending, we're enabling the depth test, but that shouldn't completely make it disappear, should it? Ah, yeah. The alpha is so low, and they're never actually, or the ones that will end up in front. Yeah, that's interesting. So let's go back into, yeah, okay, we're setting these things all over the place. So 0.2, we'll be able to see that. Okay, so yeah, they're just cutting each other all over the place. So this is not really what we're looking for. But we're going to need the depth test, against some of the other things. So when we're using these things where we need to, in order for this to work, we kind of need to disable the depth test, but then instead we have to make sure that we're drawing everything in the correct order. So this is blended on top of the things that are supposed to be behind it. Okay, this is interesting actually when we saturate this so much. Another thing obviously we can do is to just make the particles smaller. Go into particle itself here and say we could add something like particle size here. So speed, original speed, float particle, just float size. Let's imagine we take that in here with the rest. This dot size equals, let's just say 0.4 f. And we translate first, we do all this stuff, so then we do matrix dot main dot add scale, size. So now each particle is smaller, making the effect a little bit different again. Okay, particle effect. This will be 0.07 or something. We can go ahead again into the particle. Obviously this should not be here. This here whole idea shouldn't be inside the particle itself. It should be something that we can set in variables. But let's make this a little bit higher. See what happens now. Okay. Not far from it. It's fairly interesting. On my screen I can see it a little bit better, so I'm getting a bit of kind of half faded particles here. Then you can add something like, yes, they're just disappearing now. Do we want them to fade in and fade out? Do we want to add some fade in time, meaning that once we generate them, they have an alpha value of 0. Then their alpha value, and they have a fade in time, so their alpha value goes to 0 to whatever alpha we want them to be in the end. That means the particle itself would need a fade in time, it would need a fade out time, it would need a basically max alpha. And so when we generate it, and then it would need its own lifetime. So every particle would now need its own lifetime and its own update function, so that it says if I've lived less than my fade in time, I'm going to take a linear interpolation from 0 to my maximum alpha using my fade in time. And if I've lived more than my maximum lifetime minus so on and so forth. Do you want to sit and do this now? All right. Because I'm afraid there's no one showing up for the second part of this, so we can just as well go on. Put it in the recording and everyone else can see it in their own time. So, fade in time, fade out time, maximum alpha, and we need some lifetime. So when we make this dot lifetime equals 0, but the rest we need to send in here. So float fade in time, float fade out time, and float maximum alpha. Let's just call it max alpha. Okay, so lifetime equals 0. Fade in time equals fade in time. Fade out time equals fade out time. This dot max alpha equals max alpha. Okay, so what we need to do in the update function then, well then we also need a float alpha, right? And we go in here and say alpha equals 0. Or let's have this here for consistency. So in the update function now we need to say this dot alpha. Okay. Let's start here. If lifetime is less than fade in time, alpha equals, what would that be then? We're going from 0, so it's not really a linear interpolation since 0 is a special case. So we just need some percentage of max alpha. So we have it equals max alpha, except it equals something times max alpha. What would this something be? Yeah, lifetime divided by fade in time. Give us how long it's lived proportionally to the fade in time. This would be 1 once lifetime equals fade in time, but then we're not going into here anyway. This times max alpha, okay. Else, if lifetime is more than, do I have a max lifetime? No, wait. Fade in time, fade out time, max alpha. So I have, yeah, okay. So I need time to live as well. Time to
Fade out time could just not be the time when it should start fading out. No, we still need.
no, we need something to decide how. So now the particles are kind of gonna have a life of their own. So we're gonna need to change how we're throwing them out in the particle effect itself, because each one of them now has, before they just had the speed and the particle effect was keeping track of their lifetime. Now they're kind of keeping track of that themselves. The particle effects can still throw them out in the same way, I guess, because it gives them the time to live and it just trusts that they do their fade in and fade out in that time. So let's say time to live. And let's stick that in here as well. Float time to live. So everything is getting a little bit. Lifetime is 0, but time to live equals time to live. We could say time to live is something that we're subtracting delta time from every single time. So this is just what's left of it. I don't know. Like time left to live, lifetime, current time. Alright, either way, we need in the end to say lifetime plus equals delta time. So that lifetime is getting higher and higher. Else, if lifetime is bigger than time to live minus fade out time, and of course if we generate this so that fade in time and fade out time kind of intersect, then this will become weird, but let's just not do that. If lifetime is bigger than time to live minus fade out time, yes, then we're starting to fade out. Then we say alpha equals something times max alpha. And that would in this case be lifetime minus, so this time here basically. This could be optimized better, but let's stick to this now. Divided by fade in time, fade out time, times maximum alpha. Okay. Else, what do we get here? Otherwise, we're simply going for the max alpha. This would be any time in between the fade in and the fade out. Okay, so we're sending it all of this, and then this needs to actually, so this part here will now be done by the particle, since the particle effect doesn't know for each particle what it is. We could do it in the particle effect and it would kind of count through how far into its buffer it's gone, but I think this is better. So we're scaling, blah, blah, blah. Let's just stick it up here. Except this now is alpha. Okay, there are things that are wrong here.
Sensor.
Yes. Okay, particle effect obviously has errors. So we need a lot more stuff. We have speed, then we have rotation angle. We're not using that now, so we should maybe just take that out. And here as well. Or what, should we use that instead? Nah. We'll find some other way to do that. Yeah, I was going to take that out of here as well. Rotation angle. I'll get an error here. And this we don't need. Okay, fine. So particle speed. What's next? Okay, we have time to live, fade in time, fade out time, max alpha. So how long do we want them to live? They're living 1 second now, right? Let's say we fade in 0.2. No, we'll have a quicker fade in. 0.05. Let's see how that works. Fade out time, let's have that, 0.2 seconds. And what was the last thing? Okay, because I'm not putting the F's in here. And then we have max alpha. So what was the alpha? 0.07. Let's have it a bit more. 0.8. Like so. Okay, there are errors in this now. Missing an F. Okay, thank you, Java. So now we're doing this. We have to make sure now that in the update function here, we're building it like this. We're then calling update for every particle. It has its own alpha value, so we're not setting the alpha here, but we're setting the type of blend here though. They draw themselves in their position with their alpha. Is there anything more I need to change, I think? Let's see what this looks like now. Okay, they're still kind of just disappearing. They're not fading out. Am I doing something wrong? I'm saying lifetime plus equals delta time. Shouldn't need this. I'm using alpha here. Do you see anything? Let's make the fade out time longer. Fade out time just like almost the entire time. It was wrong. Wait. Something weird was happening there though. They're kind of appearing here. What are we doing wrong here?
Is the lifetime longer than?
Did we put correct numbers in here? So new particle is position, then speed, then time to live, fade in time, fade out time. Time to live, fade in time, fade out time, and maximum alpha. Let's see what happens if we change the maximum alpha. Okay, that definitely has an effect. They're not fading out at all. Setting material diffuse here, particle effect isn't affecting that.
But they move before they can start fading out. Is it possible?
Before they can start fading out. How are we removing them? We have this maximum particle count. Let's try to actually just see what happens if we don't remove them. That is pretty cool though. And now it's starting to slow down the computer just a little bit. Seriously though. I'm gonna do a little zoom out. So we can do amazing effects here. For a zoom in pan, that's cool. Something like this. Sweet. Alright, so that's not what we were looking for. In the update function of the particle, we're definitely calling the update function always for the particles. If, else if, okay, alpha always equals something. If lifetime is less than fade in time. And lifetime starts as 0. And lifetime is always. Any great ideas? Less than fade in time, they should be. None of this is integers, right? Lifetime divided by fade in time means 0 when lifetime is 0, 1 when lifetime is fade in time, okay? This fade out here, is that wrong? So we have time to live minus fade out time.
Yeah, this is wrong, isn't it?
Divided by fade out time.
It will grow. That's why it will grow as it gets closer to.
Yeah, time to live minus fade out time. Should it be the other way around maybe?
Yes.
Time to live minus fade out time minus lifetime. Are we getting a negative value there or something?
Yeah, isn't it just enough to have that time to live minus lifetime?
Now they're disappearing. Okay, add the remove again. Yeah. So time to live minus fade out time.
Shouldn't it be just time to live minus lifetime? It will end in 0 and there.
Yes. Time to live minus lifetime. But that will be time to live minus lifetime will be 1 when lifetime is fade out time away. Yes, it will be fade out time, yeah, when fade out time away. Once lifetime gets up to time to live, it'll become 0. Yeah. Is it happening now? It seems much smoother than before though, doesn't it? So if we do something like this now, say this is what happens if it's always max alpha. Just disappears up there. And instead we add the fade out. The fade out is happening now probably the entire time. Okay, this is definitely smoother and it looks much more juicy as well. Alright, and we have so many particles that we're getting the actual white center here as well. So this is working nice now. Yeah, okay, the size is fixed here. We should actually put that in here as well and say float size. And say this dot size equals size. And then go into the particle effect and say, and obviously we should also have all of these on the particle effect itself, so that whoever makes the particle effect can set all of these variables too. Let's have size here 0.4. We have time to live 1 second. We have fade in time 0.5. Let's make that a little bit longer and the fade out time a little bit shorter. See what that looks like now. Okay, max alpha a bit lower. Okay, not as interesting. So let's make max alpha higher again, but let's make the rate. Oh yeah, the rate is set then. Of course, all of this should be set in the same place. So rate is now 130. Let's make that a little bit lower. See what we can do with this. I don't know. Still looked really nice. So is this still looking nice from most directions? Sort of. Obviously we have these little kind of star. When we look at them from above, are they always like, yeah, they look like little stars because that's the way they're set up. So if this should be a 3D effect, we would actually need to not only do these, we would also need to rotate around Z or X as well to make them flat. So if we start like this, then rotate around Y, and we should rotate around X next and draw another one as well. So we can try that with the particle and say do this rotation and draw one, and then we rotate around X because the X axis is rotated with the. Okay, so then we can maybe go above and look down upon it. We don't have as much of that star effect. And just something like this is actually pretty cool. Looking like some kind of hot center or sun or plasma energy effect. So now we have a really, really simple particle effect, but still we're getting a pretty juicy and sweet effect out of this. So by changing the image, changing the colors of the image, changing the gradients in the textures to begin with, you can get more interesting things. From then on you can start setting more of these values. So yeah, we could go ahead and take all these things that we're hard coding here in the particle effect and put them in here as well. So all of these, for instance, and the size. Yeah. So that should be here as well. Take it like this and put it in the particle effect. And then steal all of this code as well. Put it in the particle effect. And some of this is irrelevant, like time to live. Now lifetime is irrelevant here, and alpha is irrelevant here. Alpha and lifetime, because those are. And then finally go in here and take the size, time to live, fade in time, like that. rate particle lifetime we have here, so we don't really need that. So we have max alpha, fade out time, fade in time, time to live, size. We have particle lifetime here, so time to live is irrelevant here. We have particle lifetime, and that's what makes the particle interval, right? No. Where's the particle lifetime set?
It isn't set, it's just used for calculating the max particle count.
Particle lifetime times rate. Yes, that's right. Okay, so then we'll use it here. Particle lifetime, like so. So now we're going to use it. And then we can probably go down here and say, what was the first one? That was size. The next one was, okay, so particle lifetime, fade in, fade out, and max alpha. Particle lifetime, fade in time, fade out time, and max alpha. So I can also go in here and say, let's rename and refactor this to particle size. Okay, now we're going to get errors here, but now we can actually set all of this in one place. So we have this, we have the rate, then this starts lifetime, size, fade in time, out time, max alpha. What's this again? So, yeah, it's the time to live. That would be the first one, particle lifetime. Then size. Okay, cool. Size was 0.4. Fade in time was 0.1. Fade out time 0.2. Max alpha, what were we? 0.07 or something like that.
0.7.
Was it that high? Okay, this works now, and we have some kind of effect. So that's a bit high for the max alpha. Let's try to set that lower and see if we can get a. Okay, and then of course, to get a stronger effect, we can make the alpha higher, or we can make the particles bigger, or we can make the rate higher so we get more particles, and we just have to decide on the detail. If your computer is struggling, then you might want to say, okay, I'm going to have a higher rate. I'm going to have a higher alpha. I'm going to have a lower rate, and I'm simply going to have a bigger size of the particles. I'm going to have bigger particles and fewer. No, that's what that looks like. And then you can just, go ahead and kind of figure out what works for you. So those are really big particles. Let's make them a little bit smaller. Okay, then we're not really getting the white center, so we need either more particles or a higher alpha. So maximum alpha 0.9 probably give us that white center, yeah, a little bit of it at least. But if you have a computer that handles it, it's much cooler to say I'm going to have 1/3 of that alpha, but 3 times the rate, and then I get the same effect except smoother. But maybe you want a little bit of that choppiness just to make it more interesting. So it's not all about optimizing for your computer, it's also just about what's cool. So now we have one point where we can control this, right here where we make the particle effect. Can make this a little bit cleaner, like so. But here we're making the particle effect and we're controlling all of these things. The size of the particles, how they fade in, what their maximum alpha is. Then we could also put things in here like, for the particle effect, like what type of blending do we want. So we could see what happens if we take this out and say let's change this to GL1. GL1 will be the same thing, except as if we have, whoa, okay, that's just ridiculous. So let's skip that. What I was going to do was source alpha and GL1 minus source alpha. So instead of just adding this up constantly, they get see-through. Okay, so this is sort of interesting, but this would probably be more interesting if we did something else here. If we went into this and said, let's use this gray gradient for this texture as well, and get a bit of a smoke texture going on. It's not a perfect smoke texture because of what's happening here, but if you were to have it inside something where the place where the smoke is being generated isn't seen, and besides it's going up pretty fast, so you'd slow that down and change a few things. You could also make that speed a little bit slower. Yeah, obviously we'd want to have that part of what we send in here, like the generation speed. But if we go now into our particle effect, where we're building this, let's have this minus 0.5 as well, so this can go in every direction then, right? And let's slow them down a lot. Times, we can do particle speed equals this, and let's just go ahead and say particle speed dot scale by 0.2, make it slower, see what happens then. Not quite what I was looking for. So then let's go back in here. Yeah, we need a longer lifetime and we need a less rate. We don't want them. So let's make them bigger. Where's the size again? Rate, lifetime, size. Rate, lifetime, size. You can actually just make them pretty big. 120 is a lot, so let's just make that 20. We have slower speed, we need more lifetime then. Wow, this is...
Fade out time.
Yeah, the fade in time. Okay, we need a fade in time. Yeah, so we need a much slower fade in time. So they're living for what, 5 seconds now. Is this the lifetime or rate, then particle lifetime? So they're living for 5 seconds. So we're gonna take this up to like give them full 2 seconds to appear and fade out as well. Another 2 seconds. We're still getting that insane kind of ball in the center, which is really weird. I don't know. Actually, okay, what could fix this is to do the same thing we're doing with the fade in and fade out, and do that to the size as well, and have like a size in and size out. But if we actually go ahead and just use the same thing for fade in and fade out for the size as well.
Is the go down the function of the image to put into a sample from the bio?
Yeah, also, yeah, okay, there's another thing, yeah, where we could randomize where they're being generated. So this plus random dot next float minus 0.5, something like this. Okay, same for y and z. So we're randomizing a little bit where we're generating them. Okay, so that's getting a little bit better. What we'd also like to do is to take fade in time and also fade the size in. I'm going to go if lifetime. Okay, so I'm going to make size and another one that's max size. I'm going to go in here and say this dot max size equals the size that we put in here, and go ahead and just change this and say size equals, of course you could set specific variables for this only, but for now let's just utilize this and see that alright, so still needs a little bit of fixing in the center there, but this is getting kind of closer to the idea of smoke. Besides, the particle texture that we're using is this perfectly clean circle. You want to make a more cloudy type of particle to begin with. But anyway, so we've taken basically the same thing as we had before, changed a few things, and we went from fire that looked like fire on the wick of a candle to smoke that kind of looks like smoke coming from a building or something like that. So if you actually had an object here which covered this place where it's being generated and you just got the smoke around it, it could be a nice effect. And besides, we've been, just for around 2 hours we've built the particle effect from scratch and played around with it a little. So at this point, in 1 more hour, we could probably make a lot of interesting energy effects playing around with this and kind of fix those little artifacts that are happening in the center. If we made right now another particle effect here in the center with the red sprite again, that could actually be really nice. That would just kind of be a little flame in the center there. Add the two together, draw them together, and you get this really interesting effect. So, anything more that we want to do with this in particular? Has it fulfilled the expectations of the particle effect demo?
Yeah.
Nice. One last thing that I want to try, because I realized afterwards that inside particle we had this code here that was just designed to make the flame look a little bit better. This should never be inside the particle, but this could be something that you can set, like speed change or speed gravity or speed gradient or something like that. We should never have this kind of hard-coded inside the particle class. I just want to see what the smoke looks like if I add this to it. I'm going to make sure I'm running the correct program here. There's the smoke. Okay, it looks similar, but it's a little bit more smoke happening here. Those stars inside and stuff. You can tweak this and make a nice smoke effect. I just wanted to see what it looks like once I take that kind of hard-coded gravity code out of there and just let the smoke keep on going outwards. Finally, we could actually go into the game class and add another thing that would be really nice here. We have rate particle lifetime. So just add to the particle lifetime, like double the lifetime. See what that looks like. bit bigger. Still looks nice. Huh. Yeah, and if we can somehow get rid of that star effect in the middle, this is really looking like... And besides, if you put a flame or an explosion effect in the middle there, that'll probably mask and hide those stars. So this smoke effect could actually look really nice combined with a fire or explosion effect in the middle. You can see that each one is living a little bit longer, not fading out until later. Nice. Another thing I was going to say, rather than putting all of these just numbers into the constructor, which makes it a little bit kind of hard to use, what we could instead do is just go into the particle effect Java, just make these things here, either make them public or do some getter and setter functions for them. And then instead of doing all that in the constructor, we can just have a plain constructor that constructs it with some default values, and then go particle effect dot fade in time equals, what's the fade in time now? 2.8. Let's have shorter fade in time, 2.0, or maybe a longer fade in time, 5 seconds in. Fade out time, 5 seconds as well. And finally, particle effect dot particle lifetime equals 15 seconds. So instead of putting these in where you can't really read what's happening, instead you make the particle effect, and then these lines will show you obviously. So the code is much more readable. What are you doing with these numbers? Fade in time, fade out time, particle lifetime, rather than just this list of numbers in here. So it will be a much nicer way to work with this. Build a particle effect with a default constructor, and then do fade in time equals this, position equals this. Some motion maybe, add a Bezier motion that it moves along. Particles are disappearing rather than fading out now. What the reason for that is? Yes. Okay. The reason for that is this. I'm using particle lifetime here to calculate max particle count. So we have to make sure we don't have particle lifetime public. Instead we have it private, and we make a setter. So we do public void set particle lifetime. So we're not using fade in time or fade out time and anything like that, no. But rate and particle lifetime we're using like this. So let's go ahead and say float lifetime, and then we actually have to not only set particle lifetime, well, we do have to do that as well. We also have to use this along with the rate dot rate. Okay. So we're going to need a floating point for rate now. Private rate, no, private float rate. We're going to need to go ahead here and say this dot rate equals rate. So this matters here, and we're going to need to do the same for set rate. Just do it like this. And obviously, okay, so we need to set the max particle count as well when we do that, and then we now do dot set particle lifetime to 15. So when we change the particle lifetime or the rate, we have to make sure that we change everything that it affects. Now, this. Now we have a nice big three-dimensional smoke effect. So it's see-through. You can go here to the edge and we can see that it's semi-transparent. But as soon as we get into the center, it's been overlaid so often that it's absolutely non-see-through, which is much like smoke is. It's see-through at the edges, it fades out, but it's not something you actually see through in the center when you're looking through the massive smoke. There we have it.